Thank you everyone for coming out. Welcome to another Techbytes event. For those of you who this is your first time with us, Techbytes is our speaker series where we invite both internal and external speakers to Spotify to join us on stage for a deep dive into some tech-related topics. Today we have Fiona Condon from Slack joining us, and Fiona is a software engineer on the machine learning services team at Slack. And she'll be talking about how Slack uses ML to help users find what they're looking for as quickly as possible on Slack. So let's welcome Fiona to the stage.
Hi, I'm Fiona, and I'm going to talk, as Mark mentioned, about search at Slack and how we use machine learning to power our search experiences. So I've worked on search for a long time. I was at Etsy for about 4 years, where I worked on search internationalization and search ranking, and then also worked on search at Giphy, where I got this awesome GIF portrait. And now for the past year and a half, I've been on the machine learning services team at Slack. And I'm really excited to be here. I love music, and I think what you guys work on is really cool. Actually, DJ'd a radio show, a music radio show for about 3 years at KPIS in Brooklyn. And when my co-host was out of town a couple times, I would compete with the music recommendation algorithms to curate my playlist, trading off songs. And sometimes I had to admit the algorithm was better than I was. So you guys do a pretty good job, and I'm pretty impressed. Cool. So this talk is going to be about 20 minutes, pretty high level. My goal is that it should be pretty accessible, regardless of whether you work on machine learning or search or not. So I'll start out by talking a little bit about the machine learning problems that we have at Slack, what we work on, give a little overview of our stack and our systems for context, and then go a little deeper on how we power our search ranking experiences with machine learning. And lastly, something I'm kind of passionate about, which is how we build confidence in the changes that we make. So, as you've already guessed, I'm sure search is a really important part of our team's domain. So a lot of people don't know that Slack is actually a backronym for searchable log of all conversations and knowledge. And I love this because I think it kind of underscores the degree to which search is really a part of the core value proposition of Slack. That when you're collaborating in Slack over the course of many years, and you put all of your company's context in that product, that having that be searchable and traversable is part of what makes that really valuable over time. And so we also work on some other things. Any kind of list of things that can be ranked tends to fall under our team's domain. So that includes autocomplete and navigation with a quick switcher and search autocomplete. And we're starting to get more into organization and discoverability, especially for big teams like Spotify that may have thousands of members and many hundreds of channels. And then finally, of course, we take on some miscellaneous kinds of use cases like spam detection, improving onboarding flows for new users, and even some kind of operational use cases. And when we're solving these problems, we have some unique advantages at Slack. So for one thing, when we're working on enterprise software and our users are largely people collaborating with their coworkers in a workplace environment, they don't have a strong incentive to be discovered in search the way that in other contexts users may. So at Etsy, our sellers always wanted to be discovered in search for obvious reasons. I assume you may have similar incentives for artists on Spotify. But without that, it can be kind of freeing since you're not competing with the incentives of the users. And we have pretty large scale, so we have more than 12 million daily active users, and the best part is those users are active in the app for on average 90 minutes a day, talking about things, interacting with people, and giving us really rich data about workplace relationships, team structures, the things that people have expertise in, the things that are interesting to them. It's a really great data set to get to work with. But of course, we also have some challenges. So the big challenge that we have that I'll be touching on throughout this talk is the privacy constraints that we have. As developers, we have no insight into what our search experiences look like for our customers, and that can make it difficult to build an intuition for our models and to make changes confidently. But also, there's strict privacy boundaries between organizations that mean that our data is very fragmented. So unlike at Google, where every user has maybe a different view into the same corpus, but largely a view into the same corpus, or at Spotify, where you have one music catalog that's presumably accessible by most of your users. That's not the case for us, which means every user is seeing a disjunct set of things, but also that we don't have what search people call head queries, or very popular queries where optimizing against that information need can have a disproportionate effect on search as a whole. So, we don't have the Justin Bieber query, where if we just nail that, we've already covered a huge fraction of use cases. Cool. So I'm going to give a little overview of our search systems. Starting with the example, maybe that I want to have a free piano, so I'm going to search my Slack workspace for free piano. So what happens when I type in this query? Well, my client sends that query to our API. We store our search documents in the open source distributed search engine Solar Cloud, but my team's domain is sort of in between those two things. Receiving the query, asking Solar Cloud for a large number of candidate result sets. So we grab about 5 pages worth of results from Solar, and then augmenting the data that we get back from Solar with a lot more nuanced signals that wouldn't be realistic to store in Solar for whatever reason. Maybe they're updated too often, or maybe they're actually specific to me as a searcher or my request in some way. So we have an internal key value store that we call CDS. We store a lot of these signals or model inputs or pieces of data there, augment what we get back from Solar with that, and then, of course, apply a machine learning ranking model to get back that page of what we believe are the most relevant results for whatever the user needs to see. And then you can see I have a little dotted line to an experimental service. We're starting to use even yet more sophisticated signals like embedding space signals. And I mention this because we're looking into using the Spotify library Annoy to serve those in the future. So how this kind of plays out is that, say these are a couple of results for my search. They're both people offering up free pianos. It's Solar Cloud's job to essentially find these candidate results, rank them by what's possible to store in Solar, something like maybe the number of reactions and replies, or the recency of the message. And then the Solar Rank service takes into account things like the fact that the author of this first message is one of my colleagues. I talk to him a lot. I'm in this channel, and perhaps rank that higher. And indeed, that is a better fit for me since the other piano appears to be in San Francisco, and that's a long way to move a piano. So hopefully I find this one. So once I look at these results, our API sends information about my query and the results to our data warehouse. My client sends logs about whether or not I click any of those or engage with them in another way to our data warehouse, and we join all that together. We use Airflow to orchestrate our ETLs, and in that process, we generate a lot of those pieces of data or signals that we store in CDS or Solar Cloud for use later in ranking, but we also emit our model artifacts, train our models, and send those for use in the rank service when we make an update. So we've traditionally used SparkML to train our machine learning ranking models, and lately we've been relying a lot more on this open source library XGBoost, which trains gradient boosted tree models. And I won't get too in depth on sort of the internals of these things, but essentially the difference between training a model for ranking versus training a model for a more traditional prediction task is that we're optimizing against what we call a loss function that is ranking specifics. Rather than optimizing for making the correct prediction about whether something's gonna get an engagement or not, we optimize holistically against the whole list of results, trying to get whatever is deemed relevant as close to the top as possible. Cool. But it's not quite that simple. So one of our challenges that I'll go a little more in depth on is actually that knowing what a click means is a little more challenging for us than it can be for other companies in other contexts. So let's say I see this result, where Sufyan acknowledges that owning a piano is a logistical nightmare. Well, maybe now I don't want to own a piano anymore, even if it's free. And so although I've seen something relevant to my interests, I've satisfied my information need, I've learned what I need to do and made a more informed decision, perhaps I don't interact with this in any way because I can read all of the text right here. And even beyond that, we have many different ways that a user can interact with a result. So I can navigate to view this in channel. I can expand it if it's too long to fit into our default size result. I can copy it and share it somehow. It's hard for us to know what all of these different signals mean in terms of evaluating whether this was relevant to the user's needs. And so one thing that's been really successful for us is using in-product surveys. When a user has finished a search, asking them using Slackbot explicitly, were you successful? What were you looking for? Did you find it? And then combining that with the session data that, as I mentioned, we store in our data warehouse, and across many sessions and searches and surveys, learning the relative utility of each type of click in determining whether a user's been successful. And luckily, there is an imperfect but strong correlation between those types of engagements and self-reported success. So otherwise, we would really have not much to do. So that is very good. And so choosing our features or inputs to the model, the data that we use to make these rankings, is also kind of got some unique challenges for us. So our major privacy constraint, as I mentioned before, when I talked about fragmented result sets, is that we absolutely can't leak any sensitive context across organizations or across companies. And so this is a fairly contrived example, but you could imagine if, Wurlitzer, the piano company, were a Slack customer and they were planning a big promotion to give away free pianos. If we were to learn any kind of a correlation between the name Wurlitzer and the term free piano, and that were to manifest somehow in the ranking for another team's search results, that would be, this is contrived, but that would be unacceptable, so we need to design to make that impossible. So we can't use raw features like you might imagine that we would feed in the query text and the document text into our models. That's a non-starter for us. We could train a model per team, but it would be very sparse. It wouldn't work well for newer teams or smaller teams, so that's kind of a non-starter as well. So the way that we get around this is using a technique from Google called attribute parameterization, which sounds a little jargony, but it's really as simple as transforming features into their non-private attributes. So rather than inputting directly channel ID is XYZ, we say, is the searcher a member of that channel? And that way, it's a non-sensitive thing that can safely be learned across organizations, and it also generalizes a lot more cleanly and requires less data for the model to understand the value of that signal. So there's still a lot that we can work with. We call it sort of like the work graph, the data that we can learn about the network of relationships at work. So as I kind of touched on before in the free piano example, the affinity between the searcher and the author of the message or the channel that it's in is a really important signal for us. And we can also look at things like how often a message has been engaged with, how often it's engaged with specifically when it shows up in search. So some very authoritative messages may frequently be engaged with from searches. And we take those alongside text features like the strength of the match between the query and the document, recency, other signals we get from Solar, and all together, that comprises a pretty powerful feature set for our models. I'm going to now talk, as I mentioned, about how we build confidence in our models when we change them and how we build confidence in changes in general. So when we're updating a model and making a pure ranking change, we use what we call offline evaluation metrics, which is just how successful the model is at completing the task that it's trained against. And so in the context of ranking, we use some ranking-specific things like mean reciprocal rank, which is a measure of how close to the top of the result sets is the first relevant result, and it decays as that gets further and further away. And mean average precision, things like that. There are a lot of ranking-specific metrics that our model training software can let us know about. And luckily, those tend to correlate pretty well with our online results. And when I say online, I mean when we run an A/B test against real users. So we use those offline metrics to decide what to experiment with and how confident we think we are. But when we're making retrieval changes or some kind of change that goes beyond just that re-ranking step of re-ranking that top 5 pages of results, that can be harder. So we do dog food our changes, especially when they're dramatic, and solicit internal feedback, but there are serious limitations to how effective that feedback can be, given how unique of a Slack user Slack is. We're a lot of power users. We use search very differently than our customers use search on average. And of course, there's a lot of diversity even within the way our customers use Slack, but we use it very heavily and in very kind of thoughtful ways that probably are pretty far away from the average customer. So we have to take that internal feedback sort of with a grain of salt. And I think this is, obviously a little bit of a curse, but also a blessing in the sense that it really helps us keep our focus on the experience of our customers in the aggregate, rather than, at previous places where I've worked, it's been easy for everybody to sort of pick a pet query or a pet, set of things to optimize against, and knowing that we can't really take our own view into the algorithms that seriously helps us stay focused on optimizing for our customers in the aggregate. So beyond just internal feedback, another thing that's been really helpful for us is building internal tooling. So we have an internal tool which takes sampled queries and replays them based on an experimental configuration against the control and the treatment. And that's been really helpful for obviously measuring some operational things like latency or validating that an infrastructural change is transparent. But also we measure ranking statistics there, and having some way of determining in advance of making a change how many searches we are going to affect and by how much is helpful, as I said, for, we do these, use it for infrastructure changes and latency impact, but also in advance of running an experiment, sizing that experiment, and determining what fraction of users we need to expose to the experiment to get statistical power on the metrics that we're hoping to move. And finally, of course, we run A/B tests. We have a pretty standard A/B testing framework. And a couple learnings from sort of A/B testing on ranking is that our users are pretty tenacious in finding something to fulfill their information needs. So they will often scroll and paginate until they have some kind of a success. And so it's a lot easier for us to affect ranking metrics like those measures of how close the relevant results are to the top of the result set than it is to inflect the overall success rate or the overall rate of searchers or sessions, which result in a click. So ranking metrics are a bit more tractable, and then we take care, just as we are always, for best practices, specifying how long we're going to run an experiment for. We also have many metrics, so we specify which ones we're hoping to move in advance of running an experiment, so that our launch criteria are consistent with what we aim to do at the outset of the experiment. Cool, so thank you so much. It's been so great to be here. Thanks for your attention. And please let me know after this if you want a free piano, because I think those pianos are actually still up for grabs. So thank you.